Hi, Mr. West. This is my third CPT recording. I did question 2 on calculating the electric field at point D. So to start, the question gives you 3 point charges placed here, here, and here. Tells you it's a square, meaning all sides are equal length. And it asks you for the electric field intensity at point D, which is epsilon. And so just to start, your only formula that you're going to use is epsilon is equal to Coulomb's constant times the charge divided by the distance squared. Following that, I also set up and right as positive. And just super quickly, to find distance c, to save us time later, it's just simple Pythagorean theorem. And distance c from point B to D is 0.0707 meters. So to start, we're going to calculate the electric field intensity on each point to D. So for epsilon A, it's going to be K times QA divided by R squared. And then for epsilon B, it's going to be K times QB divided by C squared, C being this, or this value. And for epsilon C, it's going to be K times QC divided by R squared. So following that, B will need to be split up into an X and a Y component, because we treat it like it's a vector. So now each one of these, just to save time, I already have them calculated. Please note that the mu symbol followed by the coulombs is microcoulombs, which is 10 to the negative 6. So epsilon A was positive 2.16 times 10 to the 7 newtons per coulomb. B was 8.99 times 10 to the 6 newtons per coulomb. And then C was positive 2.16 times 10 to the 7, which is also equal to A, because they're equal distance and equal charge. So this is actually negative because it would be pulling your point charge in both negative X and Y direction, and A and C will push it in this direction. So following that, now I need to sum them up. So B is important because, like vectors, you're going to split it into components. Using special triangles, if it's a right hand or an equilateral triangle, both angles inside are going to be 45 degrees. So theta in this case is 45 degrees. This comes in later when we're breaking this into components. So epsilon now on the X is equal to epsilon A, which is this value, minus epsilon B cosine 45 degrees. We're breaking this up into the vectors. That's why it looks like that. And then for epsilon on the Y, it's going to be epsilon C minus epsilon B sine theta. And so now these end up being equal to 1.5 times 10 to the 7 newtons per coulomb, and also 1.52 times 10 to the 7 newtons per coulomb. I forgot sine and cos have the same value at 45 degrees, so this makes sense. So summing them up with Pythagorean theorem using epsilon total is equal to the root of epsilon x squared plus epsilon y squared, and that is equal to 2.15 times 10 to the 7 newtons per coulomb. So that's your final value. Now, also following this, we can find the angle. And so the angle here, if you consider that it's going this way, because C is pushing it up, A is pushing it to the right, and B is pulling it down and pushing it to the left. But because A and C are bigger, it's just going to be following that path. But also because A and C have the same value, it's going to be 45 degrees. So I can explain that in a longer video if you need, but because I'm obviously tight on time, we're just going to write right 45 degrees up. And just, there's a lot of eraser shavings on this. Finding the value is here. It's just basic tan theta. So last thing that this question requires is a therefore statement, which is then simply therefore the electric field at point D will have a strength of 2.15 times 10 to the 7 newtons per coulomb. And then obviously just include the direction. So that's it for me. I hope this is okay with you. Let me know if I need to shorten it, and I can be even more brief. Thank you. See you in the next one.